Hi, hello everybody, and welcome to my talk, Lies We Tell Ourselves Using TypeScript. So if you can see this, it means that I'm sadly not able to be with you live in person to talk to you live, but believe me, I'm with you in my mind and hopefully in the chat. And I still want to give you a great experience with this talk, even if it's from the can. So let's get going. And the best way to do that is by saying, hey, I'm sorry. I'm very sorry. You have seen probably a lot of fantastic talks today. I've seen the lineup. It's brilliant. It's actually people that I long for to meet in real life again. And now it's my talk, and I will crush your hopes. I will destroy your dreams. And I'm very sorry about that. So I'm talking about TypeScript, and I talk a lot about TypeScript. So I've written 2 books in TypeScript. TypeScript in 50 Lessons, Your Guide Through the Type System, and the TypeScript Cookbook, which is here for teams who want to develop in TypeScript and have problems getting everything up and running, might have problems dealing with certain type system situations. So yeah, I spent a great deal and a lot of time with the programming language, and I like it. It's a great programming language. Look at this piece of code, for example. This is the example I usually bring when I want people to convince that TypeScript is a great idea. It's 10 lines of code or 15 lines of code, and there are more than 10 errors hidden throughout the entire program. It's not the best program, but it's maybe a program that you and I would have written back in our days. Still, it's programs that happen, and nothing in this program would have caused a crash. Nothing would have caused a runtime error. It would have just run, and it wouldn't have produced any meaningful results. And those types of errors are really, really hard to catch, and TypeScript helps us catching those things. So fantastic. This is what we are here for. This is actually great. But I'm not talking about this today. I'm talking about the total opposite. Look at this piece of code. Some TypeScript code, it's very well typed, it's complete, it compiles, it runs, and it might throw errors at runtime. Actually, it might throw a lot of errors at runtime. Those kinds of errors TypeScript is supposed to prevent. And it's just 2 functions. One fetches data and the other concatenates the results to an existing array. Parsing it right off the bat might be a bit much, so let's go through it step by step. First, we have some function overloads. We define an API to the outside world that tells us exactly what to expect if we call species or people. Function overloads are a fantastic way of doing nice and easy to use APIs. Then we have the core of the first function. We fetch some data from the Star Wars API or SWAPI, if you have heard about that. It's a great online resource to test RESTful APIs. And it also comes along with some meta information. We are not interested about the meta information, so we just return the results of this function call. And yeah, we also have some error handling in case something goes wrong when parsing the JSON. And in the end, we have a simple function that takes 2 arrays and concatenates them. Finally, we're using it. We define an empty list and embed data to it via a call to list entries. 2 functions. One fetches data, and the other one concatenates the results to an existing array. That's pretty much your standard TypeScript fare. And again, it might not be the best program that there is. Lots of stuff that might go wrong. But it's code that you and I would have written, and TypeScript is totally okay with everything that happens here. But what could go wrong? And I think everything. Actually, there's not a single line in this code base that's actually not causing any troubles. So where does it go wrong? Everywhere. And how does it go wrong? Well, one by one, because TypeScript is single-threaded. And that brings me to my most favorite JavaScript joke. Knock, knock, race condition, who's there? Anyhow, let's go through all those problems. So welcome to chapter 1, a tale of fetch. And let's look at the core of this particular statement. There's one damned lie hidden in the first line directly after the function signature. Well, actually, headline 3, I'm sorry. I'm doing a type annotation. I say that what comes back from the result.json call is of type meta of people. And this line only works, and TypeScript allows this line only because the JSON method from the body interface returns any. And any is the happy-go-lucky type in TypeScript. Everything's possible. And if I say data is matter of people, then TypeScript says, yeah, well, okay, whatever. You know best. It's any. It can be anything. It gives the responsibility to you, the developer, to make sure that the data that you assign is actually correct. And this causes for the first boom. So if anything comes back there that isn't matter of people, this program will crash. And what we see here is TypeScript at its boundaries, where the meta world of your types that nicely and neatly fit together crashes with reality. And the type system of TypeScript is fragile at the boundaries, which is mostly I/O, API calls, user input, you name it, everything where you need to read something from the untyped world going into TypeScript. And this is where you need to make extra checks to make sure that whatever happens is actually what you intend to happen. And there are two kinds of things. There are type annotations, we've seen that, but there are also type assertions. And I'd like to call those type assertions to be an unsafe operation that is at the boundary between your idea of what needs to happen and what the type system is actually able to ensure. And those things actually happen quite a lot in TypeScript. So let's look at a couple of those indicators for unsafe operations. We have as for a type assertion. It's for type predicates. Is for type predicates, and asserts X for assertion signatures. All those keywords tell us that something is afoot in the type system. They show us potential breaks because they assume certain types are dependent on what's happening in JavaScript. And TypeScript can't figure out those things are correct. So if you look at the isDice function, here we tell it that, if the number that we get in is in the array of 1 to 6, so is one of those 6 numbers, then, well, dice is a dice. So if this evaluates to true, then we can make sure that the number is actually a much, much smaller set of numbers and of type dice. But we could as easily return true in there or anything else. It doesn't matter as long as it evaluates to a Boolean. So it's just good as our programming. But one thing is important about this, that we spot those unsafe operations through a keyword, as or is. So if you look at those two lines, they basically do the same. Line 1 is a type annotation. We say, well, we are waiting result to JSON, and whatever comes back should be of type meta people. And the second line says, well, whatever we get back here, we want to treat as matter of people. And here we explicitly tell TypeScript, from that point on, I know better than you. This should be meta people. And ask yourself, if you are in a huge code base, which one of those two things can you spot more easily? I'd argue the last one, because type annotations happen everywhere, even if you have proper type checks happening. But those as type assertions, those little pushes of the type system where you say, this is how it's supposed to be right now. You can do a text search for that and see, oh, wait, there's an unsafe operation. Maybe there's something is wrong. I need to be aware that something here is happening. And the good thing is that we can enforce those type assertions. We can say, well, let's open up the interface body and rewrite how the JSON method should behave. So this is called declaration merging. Interfaces in TypeScript are never closed. So you can always extend them. You can always throw new methods at them by simply redeclaring the same interface. All previous declarations are still valid. You just add to the bottom. I mean, you have method signatures that are basically the same, but one is any and the other one is unknown. Well, then the unknown one counts more. And when I do that, when I open up global and then the interface body again, and then I say, well, this is now a promise of unknown, this line here will fail because TypeScript will tell me that unknown is not assignable to meta people in this particular line. And unknown is made for this. So unknown allows the same set of values that any does, but unknown is cautious. It's the cautious sibling of any. And it tells you, well, at this point, you need to make sure that the types are correct. And you can do that by either you're narrowing it down with your usual means, or by just saying, well, let's remove the type annotation and see as meta people. It does the same thing, but it becomes more visible that something is going wrong. All right, first problem, first solution. Next one, the theme is dark and full of errors. Let's look at this particular catch clause. It's very interesting, and I'm very curious on what has happened here. So this is something that comes from a real-world project that I had to review, and you know, I asked myself, what were they thinking? What is going on there? It's actually one of those lines where you couldn't quite spot what's going on. So the developer did actually something nice. They knew that result.json could cause a syntax error if what you return doesn't is actual any real JSON, but something different. So you're getting a syntax error, which means that you hop into a catch clause. And by the way I handle this catch clause is bogus. So you can do much better things there. But look at the type signature. Why are they calling for a syntax error or any? And the reason why they do that is that in JavaScript, everything can throw, everything. You can throw errors, you can throw objects, you can throw the number 2, all is fine. JavaScript is actually a little bit like my 3-year-old son. My son throws unexpected tantrums and I have no clue what's going on. And JavaScript is throwing unexpected errors and I have no clue what's going on. But you know, that's actually a feature of this dynamically typed language. If a type error happens, or if a synchronicity error happens, or if some syntax error happens anywhere in your code that's being parsed lazily, then this stuff can error, and you get those undefined is not a function calls, you get those type error calls. You have seen that in your console in DevTools. You have seen those things. This happens because in JavaScript anything can break. This is why TypeScript won't allow you to narrow down for very specific errors. It's a false assumption in TypeScript to say you are catching for one particular error, for the syntax error, because there are so many potential problems happening in the code above and also other errors that could occur. This is why somebody snuck in a little any. So the code says, well, it's a syntax error or it's any. And that's the truest representation of what's going on here. Because, well, either it's a syntax error, yes, from result.json, or it can be anything because it's JavaScript. But if you add any in a union with any other type, the whole type becomes any, which allows you to access every property available. This code didn't blow up at runtime is mere chance. And in TypeScript, we are not here for chance. We actually want to know what's going on. The only mitigation for that is, again, going for unknown in catch clauses and doing instance of checks. So if we activate the use unknown in catch variables flag in the tsconfig JSON, your E becomes unknown by default. You can't put it in a union because it stays unknown. And you would have to explicitly add any to make that work. So let's keep it with unknown. You can't do anything with the type before you don't do any instance of checks. Like, well, if it's an instance of syntax error, then you can do proper error handling. And again, the error handling here is bogus. Maybe if it's a syntax error, let's return a real error message and exit the whole thing. Otherwise, maybe return an empty array. So it totally depends on the semantics of your application. Okay, second problem, second solution. Let's go into the next problem. And this is maybe one of my favorites, the matrix overloaded. You know, I want to turn your eye to the function overloads. Personally, I'm a huge fan of function overloads because they allow you to design APIs like this. They tell me that I get species for the key species, for the literal string species, and I get people for the literal string people. This is what the two function signatures at the top tell me, and then I have the implementation signature. I get species with species, I get people with people. But in the code, I only return people. So again, in the signature, it tells me I get species. But in the code, I only return people. So in the signature, it tells me I get species, but in the code, I only return people. What's going on here? And this is one of the biggest caveats in function overloading. So those are all the function signatures that we have. And let's see what they mean. Let's pull them apart a little. I have two function signatures that expose the usage API. This is on the top. This is what you see when you actually call the function. And the other one, the one right before the function body, is the implementation signature. This signature is hidden when you call the function. This is just here for you to actually implement stuff. In TypeScript, there's a couple of type checks. The first type check that it does is that all the usage signatures are somehow mirrored by the implementation signature. So you can't define anything in the usage signatures that isn't defined or capable of being called in the implementation signature. This is why a lot of them are just defaulting to any, which is a very bad idea, but that's what's happening here. And the other type check that's happening is that if you are doing an implementation in the body, it checks if everything that you return actually is valid against the implementation signature. And the problem is that nobody tells you that everything that you covered in your overloads is actually being covered in the body, because the check goes usage to implementation and implementation to body, but not usage to body. This is not happening. So nothing, absolutely nothing keeps you from returning absolute bullcrap that doesn't make any sense at all. You can say, well, it's if kind is species, then return people, and if kind is people, then return species. You can do that because the implementation signature says, well, that's valid. You can do that. But the usage signatures tell you something entirely different. And nothing, absolutely nothing in TypeScript is preventing you from doing wrong to this date. One possible mitigation are conditional types. With them, you can offer the same type of parameters and return types as overloads. But since they are complex, TypeScript can't figure out what you're returning is actually what you're supposed to be returning, like here. So I'm doing here a type assertion where I assert that it's meta people or species, because otherwise TypeScript would not allow me to do anything. I would get an error and it would tell me that people or species are not assignable to type return of t. So you would need to do another type assertion here as well. You would need to act. You see an unsafe operation. You know that if something would be problematic, it would be here. Again, we are not only here to see if TypeScript has a sound idea of what's going on in the application, but also if you can spot the problems that TypeScript goes wrong. One more, last one. The unexpected virtue of ignorance. If you know what movie this is, tell me afterwards in the chat. And this is arguably one of my very favorites because it's so simple yet so painful. And we endured a lot of pain already, didn't we? So in the second function, I have a function called append entries. Append entries takes a list of people or species and you concatenate them with another list of people or species. Fair enough, since the parameter list is passed per reference, it mutates the list, but look at the actual usage. I create a list of people and I append entries of type species. So the type of list before I call append entries is people. And what's the type after I call append entries? Sorry? Here, what's the type of list after I call append entries? It's still people. It is still people. And the reason for that is that all the contracts for TypeScript are fulfilled. You are getting people in there and you're getting species in there, and the function accepts people or species. So, well, the types check out. Everything is okay. But the problem is that TypeScript can't react to object mutations that happen if you pass something along by reference, which you can argue is actually a problem of JavaScript itself. But still, it's something that we need to deal with. And one thing that you can do, how you can deal with it, is by adding generics. So in generics, you instead of the broad type that you have here of array, people, or species, you add a generic parameter of the same type. So you say, well, whatever we put in there is a subset of people or species array. And then you set the list and from to the same type. And the moment you call this function, TypeScript locks t to the concrete type of the first parameter and tells you that you can't mix and merge as you see fit. Now you need to act. So here it says, well, the argument of type promise species is not assignable to the parameter of promise people, because with adding list at the first parameter, t becomes array of people, and because of that, from also needs to be of promise people. All right. Everything mitigated. 4 problems, 4 solutions. Let's enter the final chapter. Lies, damn lies, and TypeScript. So the story so far. We found 4 mitigations to 4 problems. We used declaration merging to patch assumptions, used here as reset by Matt Pocock. It's a fantastic library doing exactly that. You are doing instance objects and unknown in catch clauses to work with error types. You use conditional types instead of function overloads to provide a similar API and highlight unsafe operations. And last but not least, you add generics to allow you to narrow down to specifics to make those type parameters concrete with usage. So far, so good. More lies, more damn lies. Every solution that I told you just comes with more damn lies. Here, declaration merging. I declare an interface that is called form data. And the moment I use it in handle form, I can access APIs that I haven't defined. Where are those APIs coming from? It's because form data already exists as a global type and I merge with a global type. So declaration merging is fun until you accidentally merge with globals and say, don't say this is artificial. I know so many people who had exact this problem. And that's why. This is my favorite, undoubtedly. So instance objects, hooray. I have 2 classes, class A and class B. Both have a very distinct property. Class A has the property A, class B has the property B. Then I have a doSomething function that accepts both A or B as parameters. To access the correct properties, I do instance objects to get the right type in the control flow. So after P instance of A, TypeScript knows that P is definitely 100% of type A. Right? Right? But hey, TypeScript is a structural type system, which means that I can just pass elements which have the same shape as A, and this will compile. But, it's just of the same shape of A. It's not an instance of A. So JavaScript only allows the instance object to happen if you actually constructed the class with new, not if you pass something that looks and feels like A. So TypeScript allows that. JavaScript instance objects don't. But TypeScript instance objects narrows it down to the wrong type, which means that in the else branch, I would access B, which isn't there. It would be undefined because I have A of 42. Okay, this will cause this function to log undefined, but think about, calling this parameter times 2 or something. You will get an error at runtime. So yeah, instance objects are great until you realize that TypeScript is structurally typed. Conditional types. Yeah, I'm sorry. Anybody knows what's going on there? I don't, and I should because I've written this February, and I've even a 5-page explanation in my book, the TypeScript Cookbook, and I couldn't tell you what's going on there. So conditional types are powerful. They are incredibly powerful. But, it's like from the creators of regular expressions comes the sequel nobody wanted. They are complex, and you really need to think about if you want to add this kind of complexity to your code base. So they are hard to pass. They are hard to write. They require documentation. Use them wisely or don't use them at all. Ask yourself if the complexity is worth the benefits. That's all I'm saying here. And last but not least, generics. Generics are great, but they can be explicitly annotated, and then you have the same problem as before. So be aware that generics are a solution and a very great solution. So I use them a lot, but they are not the solution. And with that, all of our solutions debunked again. More problems, more solutions, more problems. Let's go to the end. Again, I'm sorry, this was not a nice talk. I hope I didn't crush your hopes or destroy your dreams. You are here to learn something, to get excited about TypeScript, about JavaScript. You have seen so many great speakers, and I adore all of them. They are fantastic. And now you hear a grumpy 40-something talking about stuff that goes wrong with his computer. And you might ask yourself, so after all of that, I've written 2 books on TypeScript. I've given countless talks on TypeScript. What do I think of TypeScript? Well, I fucking love TypeScript. It's still the second best language I have the pleasure to work with. And I wouldn't want to work without it. Seriously, TypeScript is actually not about a sound type system. It's about making you productive. And I just can't argue with the fact that TypeScript makes me tremendously productive. And you know what? This title is not called The Lies TypeScript Tells Us. It's called The Lies That We Tell Ourselves as Developers. And there are a couple of lies. There are lies that, well, our type system should be sound. That's a lie we tell ourselves when we use TypeScript. And another lie is that we are here to write code because we are not, in reality, software engineering, and you all are software engineers, is about decisions and trade-offs. That's our job, and that's what we are supposed to do. Code can be written by a Copilot. My code is written by a Copilot plenty of times. But the code that I commit to our repository, that decision was made by me, and I need to understand what's going on. I need to understand what's going on in the code, and I need to understand the caveats of the tool. Only then can I make the decision if one line of code enters our repo or not. It's about the trade-offs of the tool and the decisions I make. And who knows a lot about decisions and trade-offs? TypeScript and the TypeScript team. Look at that, it's an explicit non-goal of TypeScript to be provably sound, which is a very bold statement for a type system. But what they want to do is strike a balance between the correctness and the productivity. It's a goal to make you productive as hell, making all the little trade-offs that come with the type system that sits on top of JavaScript, and that's okay. The TypeScript team are some of the smartest people I had the pleasure to meet. And it's tremendous what they do to formalize a programming language like JavaScript that's supposed to go haywire if you just look at it. But that's software engineering, and that's my point. My point. We are all developers, and every line of code that you write is a decision that you make. Every tool or library that you use has trade-offs that you need to be willing to take, and there is no silver bullet. So don't feel yourself superior because you use a certain tool. A language everybody loves to hate is PHP, but hey, here is Taylor Otwell, the creator of a popular PHP framework, showing off his Lambo, that PHP bot. And then here you have, lo and behold, the Austrian Java Fiat. I mean, hey, if all you need to do is carry kids and beers, which car does the job? I'm a Rust developer, by the way, so have a guess what my car looks like. And that's a stupid status symbol, but the key is there that everything that we use is just a tool, and you need to be aware about the caveats of the tool. Because I'm not here to tell you what to do. I'm not here for the 5-minute hot takes that go viral on YouTube. I'm here to make you aware that nothing is without its caveats. It's about trade-offs, it's about decisions, and it's about productivity. And with that, I want you to be pragmatic. I want you to be aware of the trade-offs you make with the tools you choose, and use this information to find and choose the best way possible for you and your team. No solution is the best thing possible. It's just a solution. One thing that was interesting, I think that's also the reason why TypeScript in the end is so immensely popular, that they make this decision of allowing a couple of type system flips for the sake of productivity. There was another type system years ago called Flow by Facebook, which was syntactically very similar, tooling-wise very similar to TypeScript, but also very strict and provably sound. And I was at a conference a couple of months ago where I gave a similar talk to this to an audience of 4,000 people. And about everybody in the room knew TypeScript and worked with TypeScript. 3 people remembered that Flow even existed. And I think this is because of the decision that the TypeScript team made in the past to allow the type system to be a little bit wider and not provably sound for the sake of productivity. So it's just a solution, and it can work for you, maybe it doesn't. Don't go for hot takes or dogma. And I know that this phrase on the slide is also very dogmatic, but beat me. And with that, thank you again for having me. Again, I'm sorry that I can't speak to you in person. As you might heard right now, I like to speak a lot and I like to talk a lot, but something is preventing me from doing so. I still hope you had a great time. I still hope that I will be around in the chat to take your questions and to hang out with you a little. And with that, I want to thank you very much for having me. And if you want to know more about TypeScript, I've written 2 books. They are out. Both are fantastic, and I can highly recommend them. But hey, why wouldn't I? Right. See you. Bye-bye.